we're going to move ahead to section 5.3. And the question that we want to address in section 5.3 is, can I graph this function sine of t? Really graph y equals the sine of t. And to do that, I'm going to use a little bit of a trick to make it easier on myself by going back to the definition of the sine function in terms of the unit circle. Now, the way we define sine, we've started with the point here. We've measured some distance around the circle, so if we did it for a specific one, say you had that distance t, and whatever that terminal point is, the sine is the second coordinate of that point. But notice as we go around, when you get to a total distance of 2 pi, you're right back where you started. So I should be able to just figure out what the graph of the sine function looks like between 0 and 2 pi, and use that and just repeat it over and over again. And this is what's called periodic behavior. What I get is that the sine of t plus 2 pi equals the sine of t. Now I could also do that right here if I wanted 4 pi or 6 pi or negative 16 pi, some even multiple of pi. 4 pi would just mean going around twice. Negative 16, I'd go backwards 8 times. I should be able to have that. So if I just figure out what does this graph look like between 0 and 2 pi, that should be enough. So let's take some points and see what we get. Well, I'm going to need values for t and values for the sine of t. Now there's a few values for t that we worked out previously. When t is 0, pi over 6, pi over 4, pi over 3, pi over 2. And we know that for these common lengths, the sine was pretty easy to calculate. We've got 0, 1/2, put 2 over 2, put 3 over 2, and 4 over 2, which we showed previously, is just equal to 1. So that's all well and good, but we notice that all of these values, all of these lengths, are only going to give us points in the unit circle that's in the first quadrant. Now if I look at the circle again, if I'm just in this first quadrant, the y-coordinates of every point on that section of the circle are positive. And in the second quadrant, the y-coordinates are also positive. But once I get down here into the third and fourth quadrants, the y-coordinates are negative. Now I'm going to be able to exploit that to figure out how the sine function is going to behave. So if I start here, where t is equal to 0, I know that sine of 0 is 0. And from what we see here, these are all increasing in value, but they get up to 1, and that's as big as they're going to get. Increasing from here up until we hit 1, and at pi over 2, sine of pi over 2 is equal to 1. We're going to decrease from there until we get over to here. The y-coordinate here is 0, and that's going to happen when t is equal to pi. And then we keep going. We got to 0 there. Keep going around. Now this is exactly opposite of where I was up here. So down here, pi over 2, 2 pi over 2, which is just pi, 3 pi over 2 down at the bottom, 3 pi over 2, and sine 3 pi over 2 is negative 1. So as I travel around, and then of course when I get back to 2 pi I'm back here. My sine starts at 0, it increases continuously until it hits 1, decreases nicely back to 0. Keeps going down to negative 1, and then goes up again until it hits 1. I'm measuring how the y values change as my lengths move around the circle, forwards and backwards. But I only need to start from 0, travel around until I hit 2 pi, and I should have it. So let's see if I can put that all together. So there's my origin at 0, 0. Here's 2 pi. Let's put 1 pi halfway in between. 3 pi over 2. Pi over 2. And we know the function goes back and forth between negative 1 and 1. From what we saw here in this circle, pi over 2, sine goes to 1. Sine of 0 is 0. Sine of pi, we were back to 0. 3 pi over 2 goes down to negative 1. And 2 pi goes back to 0. Now you can plug in some test points in between these to get an idea of the shape of the graph. Your book does that for you, gives you a lot more points than I've done here. But as we trace this out, we get something roughly like this. Now it's periodic, so if I need to know what's going to happen on the other side, it should just continue over here. It's just going to continue until I run out of room. And I'm going to be able to move it like that as far as I want in either direction. So we've got a nice idea of the sine function, what it's going to look like. It's going to get this, this wave pattern. It's actually called a sine wave because it's common enough to get its own name. And for the cosine, we're going to expect some similar behavior, but we need to be aware that the values of the sine and cosine are different. In case of the cosine, again, unit circle, looking at values for t and cosine of t. When t is 0, we're over here, but the cosine is not the y-coordinate, it's the x-coordinate. So when t is 0, we go to 1. Let's check pi over 2, pi, and 3 pi over 2, because again, we're going to get nice periodic behavior, just like we did before. When we go up to pi, the x-coordinate at pi over 2 is 0. The x-coordinate at negative pi over 2 is negative 1. 3 pi over 2, we're back to 0. And then at 2 pi, of course, we're at the same place we were when t was equal to 0. And you get the same periodic behavior. So it's got a similar bound to the way the sine function works. It's always between 1 and negative 1. But instead of, like the sine function, when t was 0, the sine function was 0. Now when t is 0, the cosine function is going to be 1. So we're going to get a very similar graph, but it's going to be shifted over. 1, negative 1. Stick 2 pi out there, pi in the middle, pi over 2, and 3 pi over 2. So when the cosine is 0, or rather when t is 0, the cosine of 0 is 1. Down until it hits 0 at pi over 2. Down to negative 1 at pi. Comes back to 0 at 3 pi over 2. And comes back to 1 at 2 pi. And because it's going to be periodic, the same way the sine was, because it's derived from going around the unit circle, I can take this and just keep going. So in the next section, we'll finish up 5.3, and we will look at some properties of these graphs and how, as you change the sine and cosine function a little bit, how the shape of the graph is going to be manipulated.